All right, so we're going to do problem number 4 on worksheet 8, molecular polarity. So this is H2S. So we're going to start by identifying how many valence electrons we have. So we have sulfur, and we have 2 hydrogens. So I'm going to figure out my valence electrons. 1 sulfur times 6 valence electrons, E. And 2 hydrogens times 1 valence electron. So that's 8 valence electrons. So I'm going to take my central atom, which is going to be sulfur. I'm going to put my hydrogens on either side. I'm going to connect them with a single bond. So that's 2, 4. So I've used 4, meaning I've got 4 valence electrons to find a home for still. Hydrogen is that special atom that doesn't need more electrons once it's participated in a single bond. So I'm going to put pairs of electrons, my remaining 4 electrons, on my central atom. Now sulfur has 2, 4 electrons in a bond and 2, 4 electrons in unshared pairs of electrons. So the sulfur has 8 valence electrons and the hydrogen has 2. Again, we have our central atom, A. We have number of atoms bonded to the central atom, which is 2, X2. And then we have unshared pairs of electrons, which is 2 on the central atom. So just like the problem from before, that molecular geometry is going to be bent. So the next thing we need to do is identify the type of bond we have. So we have H, and we have S. So we're going to go and figure that out. So hydrogen has an electronegativity of 2.1. Sulfur, according to the periodic table, has an electronegativity of 2.5. When I subtract them, I get a value of 0.4, meaning that this is going to be a non-polar bond. Non-polar bond. So if it's a non-polar bond, I don't have to draw any arrows. And if I don't have to draw any arrows, now I can focus on molecular polarity. Now, even though the bonds are non-polar, I'm going to tell you that in this particular instance, this is going to be a polar molecule. And it's going to be a polar molecule because there are 2 unshared pairs of electrons on the central atom, creating a large area of negative charge on the central atom. So again, if there are any electrons on the central atom, a lot of times that makes the molecule automatically become polar. And the reasoning is that those unshared pairs of electrons create a large area of negative charge on the central atom. So those are the 2 things we're going to be looking for. Unshared pairs of electrons on the central atom, and those unshared pairs of electrons create a large area of negative charge. So that's the answer, the solution for question number 4. If you have any questions, go ahead and let me know. Otherwise, hopefully you got this one right.